Hello everyone, this is Shannon from That's So Po, and today I'm doing a discussion of the book The Ethical Algorithm by Michael Kearns and Roth. This is a book that I read for my social justice nonfiction project, which I will link a video to below if you're curious. This book talks about the way that we can design algorithms for machine learning and AI to include ethical constraints. So in this video, I'm going to talk a bit about the ideas that are discussed in this book and what they suggest we do. I won't go into too much technical detail, but just really think about what ideas they bring up and why those are important. So first, this book talks about the reason why we need to have ethical constraints on algorithm design. If you're not familiar with the way that machine learning works, basically you have a ton of data, you give it to a computer, and you give it an objective. Often that objective is something like to make predictions with a certain amount of accuracy. And the computer will look at the data, look at the objectives that it's trying to reach, and it'll make whatever decisions it wants to make to build that model. So humans aren't really involved in that. Unfortunately, often computers will take the shortest, simplest, easiest route, which sometimes crosses boundaries that as humans we would never make. And it can do things like when deciding who to give a mortgage to, it can make decisions based on gender or race or any sort of other things that we say that's not an acceptable thing to base a decision on. So it's important that as people who design algorithms, we constrain the models to only make ethical decisions when trying to reach that objective of accuracy. And there are some efforts to make laws and regulations to do this, but often those are much slower moving than how fast the field of machine learning is going. Every 6 months in machine learning, there's some new algorithms, some new things that come out, and lawmakers just can't keep up with that. So that's what this book is addressing, is how can we add these ethical constraints, which are needed in order to make sure that everybody is treated fairly, make sure that we are respecting privacy, make sure that our models are behaving in a way that is consistent with human values. Next, the authors talk about the issue of privacy. Privacy is one of the areas in the research of ethical algorithms that actually has had a lot of traction and a lot of interesting work has been done. So privacy is this idea of when your data is used to build a model, you don't want that data to provide personally identifying information or information that could be used to harm you in some way, such as perhaps exposing your religious beliefs or your sexual preferences or any of that sort of thing. And this can go quite wide in terms of the amount of information that could be about you out there. So the issue with this is that because all of these models are built on lots and lots of data, it's very hard to keep that information private. Not just in terms of breaches where information that is held secure is suddenly exposed by people hacking into systems, but also in terms of just the way that the data is used. So they have a great quote in this, which is, "Anonymized data isn't," which is the idea that even when we're trying to anonymize data by removing personally identifying information, often it can still be figured out. So they give the example that Netflix released a big data set about Netflix users' preferences, and they removed everything that was personally identifying, and they wanted people to kind of work on building new models that could be very good recommendation systems. This seemed perfectly fine, except that it wasn't, because a lot of the times there's other data sets out there that can be triangulated to figure out personally identifying information. So it turned out it was very, very easy for people to look at Netflix user records, even though all the information had been scrubbed other than what they liked and disliked, and compare that to IMDb user records online, where people often would review different movies. However, the IMDb profile was a public thing. People would often use their real names, and what they're reviewing there they know is going to be public, but they didn't realize that their Netflix preferences would be public. And so maybe somebody had liked something very compromising in terms of their religious or sexual beliefs or whatever, and that could be triangulated to actually figure out who had made those likes and dislikes on Netflix. And this is kind of typical. It's very typical that a lot of information, even when you try to remove information that it could be identifying, still can be figured out. And one of the key things too is that once you release a data set into the public, it stays there forever. You know, what is online stays online, and you don't know what kind of other sources of information are going to be available later that it could be triangulated with. Even beyond that, there are big issues because even the models that are built often can be reverse engineered to figure out what data they were trained on. So there's a lot of issues regarding this. However, there is some pretty interesting research that they talked about on how to deal with this. The most interesting thing is this idea of differential privacy, which is when building the model, you have all this data, but you can add in noise, random noise, to the data and mess up the records so that it can change true to false, it can alter values, it can mess with the data to introduce noise in a random but systematic way so that you can still build a model that overall has the same kind of distribution as the population, but for each individual record, you don't know what information was truly there before versus was introduced through this kind of noise adding mechanism. And this is really important because that means there's kind of always plausible deniability, right? You never know if information is true about a person or not. And this can be important for things like government subpoenas. A lot of big companies like Google and Apple and things like that get tons of government subpoenas for information about users. But when they use differential privacy with this noise added in, the information they give those government groups is kind of like, well, this is what we have, but we don't really know what's true and what's not. So that's kind of one of the interesting areas of research in privacy right now. Another big topic covered in this book is that of fairness in algorithm design. So when we're trying to design algorithms, we want them to be models that are fair to all groups of people. Unfortunately, this is very, very hard to do because algorithms are based on data. And the data sets that we collect often are not fair because life is not fair and there's so much bias in the real world that shows up in the data. Unfortunately, these models often not just repeat that bias, but exacerbate it and make it much, much worse. So an example of this is there's a very famous paper, which is man is to computer programmer as woman is to homemaker. And the idea is that when building a model, which kind of can do word analogies, they were finding really sexist results. And the reason why is because that sexism was present in the data. And sometimes it's not even something as overt as women are only homemakers. It can just be something like computer programmer, the word, tends to only co-occur with the pronoun he, whereas homemaker tends to only occur with the pronoun she. And so the computer is like, oh, man is to computer programmer, you mean an occupation that I see only with a male pronoun? Let me give you one for a female pronoun, and you get homemaker. And it's not intentional. It's not intentional by the people who designed the algorithm or the people who collected the data. It's just there in terms of the way that society is built, the way that our data is, and it's really, really pernicious. It's very hard to get rid of this bias in machine learning models because they have no sense of ethics. So we have to therefore enforce ethics. We have to do things to say, in this model, you can't treat men and women differently. You can't treat people of different races differently. And it's very difficult to do. There's a couple of different ways to approach it, looking at, for example, just having statistical parity, so making sure that the same percentage of people of different groups are represented, that sort of thing. But even that is really hard. There's something called fairness gerrymandering. So this is the idea that a model, even if you tell it, hey, you can't make decisions based on gender and you can't make decisions based on race, it'll say, okay, I will create some model and that will have equal results for men versus women, and it will have equal results for like blacks versus whites. However, if you actually look at it, at the intersection of different identities, you don't have fairness. So if you've ever heard of the idea of intersectionality and how people at the intersection of different identities sometimes get very much the short end of the stick, this can happen with computer programming and machine learning so easily. So for example, maybe you can have totally 50% for men, 50% for women, but you maybe only have 0% for Black women, even though you still have 50% total for Black and white. And so it's this idea that at the intersection of identities, it may not be fair, and you can easily get identities that are very, very complicated. So trying to specify all of that for a machine learning model is actually quite complicated. And this is definitely an area where there's still a lot of research going on and a lot more needs to be done because it's quite important. The other thing that's quite difficult about this is this idea of pernicious feedback loops. So right now, there are a lot of places where machine learning models are being used. They're being used in the real world for things that they should not be being used for. And when they're used, they base a model off of biased data, they give biased results, and then those biased results are enacted in the real world, which therefore creates more bias, which creates more data, which is then fed back into those systems, confirming their previous beliefs. So an example of this is police dispatching. So there are some cities in the US that use models that tell them, oh, you should dispatch officers to this area at this time. These models are designed to limit crime, but what it's really doing is it's creating a feedback loop of arresting more people in the places where more arrests have historically happened. So what that means is that because more arrests typically happen of Black and brown people than of white people, you're gonna have more data in the system of arrests being made in those areas, and then the police are gonna go to those areas, which means they're not looking for crime in the white areas, which means that any arrests they make are going to be Black and brown people, which is going to then feed back into the system. So it just creates this spiral of continuing the bias and making it worse. So it's a very important topic, and unfortunately, not enough has been done yet in this area. So this was really interesting to read about kind of the issues as well as what little has been done. The other topic that was explored in depth in this book is that of game theory. So game theory, if you're not familiar with it, is an idea of looking at the way that people cooperate or act selfishly when they're in the same game and they're all trying to optimize the results for themselves. Basically, there's an idea of a selfish equilibrium, which is that in general, the safest option is to look out for only yourself, even at the cost to other people. Sometimes there's an idea that if you had all cooperated together, everybody could get a much more optimal result. But to do that, you have to care about everybody else and you have to trust that they are going to act in your best interest, which is not always the case. So game theory in general, the research shows that the safest choice is to be selfish, look out for yourself, and maybe hurt other people in the process. And what they found is that in a lot of machine learning algorithms where multiple people are present, this kind of plays out as expected. So things like, for example, Google Maps. If you use Google Maps to figure out a route, it will tell you, oh, this route has the fastest travel time, it has the least traffic. But it's telling that to everybody else who is also traveling, and if everybody takes that route, it is no longer the shortest one because now it has a ton of traffic and it's backed up. And this happens in real life. The issue is that the algorithm is trying to optimize for each individual user rather than looking at the benefit of the whole. And so there's some ways, some approaches, methodologies that have been used to try to mitigate this. They talk about this idea of Maxwell's equilibrium, which is that if instead of trying to optimize for each individual, you give the model the objective of optimizing for outcomes overall, so that over all of the users there is a reduced travel time, then you can get better results. The problem is that people don't play nicely with things like this. So It doesn't work if you have people who opt out, like they decide they're not going to use the system if they're not guaranteed the best travel time, or if you have people who try to game the system. There was an interesting example of some neighborhood in LA where there were people who had learned that they could report accidents, and in doing so, the map system would route other people away from it, which would mean there would be like no traffic on that route, and so they could go faster. So there's issues when you have users who may not want to play nicely with the system if you're trying to optimize for everybody. But they also talked about how differential privacy can be used in a similar way, where you can add some noise and reduce the impact of any specific user such that it still gives a pretty optimal outcome overall. But I think this is also one of those areas where not enough research has been done, and it's going to be really interesting as we have more and more systems that come online that everybody uses, that we're all looking out for ourselves, but also sometimes if we don't cooperate, things don't go well. So those were the main topics that this book covered. It did address a couple of others briefly, things like the scientific reproducibility crisis, things like echo chambers, things like interpretability and AI safety. So there were some other topics as well, but a lot of these don't necessarily have a ton of research as to best practices, and this book really was looking at best practices. Overall, I think that this book was a really good introduction and overview to kind of the state of the art, some of the methods that we have been using to create more ethical algorithms. I do think that it's a little sad how much really has no work done on it. Interpretability is something that's only just starting. Things like morality are not even looked at. So it's a little interesting how many areas there are for growth, but it's neat learning about where we are at this point in time. I think that the criticism that I would have of this book is that it doesn't necessarily work for most audiences. I would say that if you don't have a machine learning background, but you still have a technical background, computer science, math, that sort of thing, this is still accessible for you. But if you don't, it's probably going to be a little dry and not necessarily what you're as interested in. If you are interested in the topic though, and you would like to read a book understanding what the issues are, then I would really highly recommend Weapons of Math Destruction by Cathy O'Neill. This book does a great job talking about how algorithms can be unethical and how they are impacting society. I think that book is such a great read and really introduces you to what the issue is. The ethical algorithm, on the other hand, is more just an overview of methodology for how to create better algorithms without necessarily addressing what all of the issues are. So if you're somebody who's technical and you're just interested in learning more about how these algorithms could be designed better, this book is good. But also if you're technical and you know a little bit more about this, I would probably suggest that you just go straight to looking at journal articles about these things, because that's going to provide a lot more detail about the actual implementations. So I hope that this discussion was interesting, both to people who may know something about the topic as well as to those who are newer to the topic. Let me know down below what you think, if you've read any good books on this topic, if there's any new ideas that I talked about that are interesting to you. I'm also just really interested in this in general and looking for recommendations at any point. So if you have any recommendations, go ahead and let me know below. And if you're not familiar with this topic, I think it's a really interesting one to look into, because as we move forward, there are going to be a lot more algorithms used in things that affect us in daily life. And unfortunately, they are going to affect people who are already suffering the most inequality and bias and oppression the most. So it's important for everybody to kind of be aware of that, so that when we hear about AI models being used, we can be a little bit more informed and questioning those uses and questioning what the impact of that is and questioning who is going to be harmed if those algorithms aren't designed with ethics in mind. So let me know in the comments any thoughts you have. I'd love to hear from you.